Loud, or is that good? Okay, we're going to start. My name's John Whitney, and we're going to go through a lot of slides, about 100, and so we're going to go quick. And so I want you guys to keep up with me. I have my assistant here, Stephen. And Stephen has taken a day out of school to come here. How many more days do you have to go?
1 day.
Okay, 1 day. Okay. So if you're here for in-depth Perl, that's the wrong room. We're eventually going to get to Perl, source filters, modulicious, C-SPAN modules, but we're going to cover a few other exciting things first. My name's John Whitney, got a computer engineering degree in 1980, and I'm still in software development today. I already introduced you to my technical assistant, Stephen. And in the beginning, you probably all know what the first computer was. It was Emmerich. And we're going to join that world.
One, two, and throw. And the Good heavens, what have you done now? I don't know. Now, calm down. You know you have to tell me. I can't fix it unless I know the secret.
I don't know what I did. I don't know. It's your machine, not mine.
Is this thing supposed to be sobering?
Don't you touch that machine.
No. Stop crying. Crying won't help it just because you made a stupid mistake.
Well, the stupid mistake she made is she used Perl 5 and not Perl 6. So even back then they had problems, and it was a much more exciting time. We're going to enter that time. So 2 years ago, I asked myself, would it be possible to mix old and new in a way that would be useful and that my kids could use? And so who here today, I'm going to ask a few questions, who here knows what or knew what a teletype was? Oh, quite a few of you. And who here has seen one working? Oh, fair number. Who has used one in their work? Oh, we got one. Okay. So he and I are the only two who ever used one in work here. And then my last question is, who here is a member of like an employee club? What? Okay, you'll see how that's important when we go later. But the goal was to get this talking to the internet cloud, and to get news, weather, email. And so the goal here was to we're actually bridging 50 years of technology. In 1964, this product came out, the teletype, the ASCII teletype, and now we're in 2015. So all the components to make all this work, basically you have terminals, you have converters to get those terminals to talk to a Linux machine, and then you have the Linux machine who need a little bit of custom software so it could then talk to the cloud and get everything back to the terminals and so forth. So we have a complete loop between these. So the teletype terminals. Why teletypes? Well, it turns out the teletype company pushed electromechanical design to its limit, and it was almost pure genius in many of the things they did with clutches and mechanical mechanisms to do functions and so forth. They were the first I/O devices for some of the very early computers. I mean, these devices were used when there were no computers and they were just communicating over phone lines. And later they were adapted to computers because they were just there. The other thing that's interesting is these machines will still be running 100 years from now. They're basically electromechanical. There's very few, there's like one transistor in there, a huge one, and maybe a couple resistors, but there's almost nothing in there that's digital. So the goal here for our terminals is they had to be able to print, type, and read and punch paper tape. And I needed two of them because I have two kids. And they should be identical so they would prevent any arguments from the kids. Oh, yours is better than mine. And they had to be fairly lightweight. They had to be under 70 pounds so we could get them up and down the stairs. So what was available? So in our house, in the garage, we have these Model 35 KSRs. These are workhorse machines that are run 24 hours a day. The one that says octopus was on a system that was used at Lawrence Livermore Labs in California. But they don't have paper tape punch, so they're useless. These machines, they're 35 ASRs, automatic send and receive, but the problem with these is they weigh 220 pounds, and it's a little hard to get them up and down the stairs. They do have the paper tape and punch, though. So then we had these under the stairs. These are the Teletype 33s, and I said, okay, these are perfect. They weigh 70 pounds, they have paper tape punch, and they can print, so they'll need to be restored, though. They've been sitting there for a while, about 10 years. So you might ask yourself, well, where could I get one of these machines? Well, they come up on eBay about 5-10 times a year, and they range in price from $500 to $3,000. This one sold in March 2014, just about a year ago, for $2,300. And it was, I believe it was a non-functioning one, but it was in fairly good condition. So what do you do to restore one? You basically completely take it apart. And these machines were designed to be serviced. I mean, they have manuals here that you can look at. Everything is discussed and explained. Where to oil, how to take it apart, how to put it back together, what you need to worry about. And it's quite modular, too. And you can see I have most of the pieces taken apart here. And as you go through it, you're just looking for anything that's bad. And in this particular product, it had, you can see cracks on this belt. So that belt's going to have to be changed. And on this one, you notice there's a tooth missing on that gear when I pulled that out. So the question is, where do you get parts? Well, it pays to have a spare parts machine. Or it pays to know this man. This is Paul. He's in California. And he has millions of parts. Literally millions of parts. He's been in the business of repairing these machines for over 40 years. And every little part you can imagine he's got. Now, he doesn't have everything because there's no new supply, but almost everything he has. And he has tons of knowledge. This stack up here goes about twice that way, and it's all manuals on how to repair the machines. Okay, so this is the side of the keyboard, and just to give you an example, this keyboard has over 100 oiling points. But you got to make sure that none of the oil touches in here because it will short out these circuits. So you got to be very careful what you're doing. These are the feet. Somebody decided they would spray paint it and just took all that off. I restored the ribbons by just re-inking them. Then you start putting everything back together. And it pays to put everything in numbered bags. So you just reverse order. You take what's in that numbered bag and you pretty much can figure out where it goes. And another nice thing to do is these rolling platforms are extremely helpful. You can turn the machine around. It's very easy to work. You don't want to work on a fixed platform. And the kids were getting a little curious. What was I doing? And this is that same machine now restored. This is a brand new belt. It's got a gear from another machine. And you can see how it's quite cleaned up now. And these are how it looks inside. These are actually called code bars, and they go up and down to do the 8-bit ASCII characters. This is an example of the oiling that you have to do. There's 50 pages of oiling instructions. This is half of one page, and it just tells you got to put oil, D, you keep it dry, and another one is G, where you put grease. And those are the three things, O, D, and G, and everything was labeled. So I started oiling and greasing everything. And now I finally had it working. This took me about 6 months, and then I buttoned it all up, and this one was done. Okay, but I need a second one, so I'm going to restore a second one. But I'm not going to go into so much detail. And this machine, the second one I restored here, was almost brand new, so it was very easy to do. And we're going to do one historical tangent. Here's an example of the keyboard. Remember I said there was 100 oiling points. If you can look, every one of these things has a requirement to be oiled. And every time you turn these on, if they've been sitting for a while, you got to hit all the keys, get them all working again before you really try to do some productive programming. You don't want to drop anything on this keyboard when it's in this state because it's really hard to get all those keys back lined up again. And the kitchen sink was wash central. We washed all the parts. You can see this is a newer design. They actually put a plastic cover here to prevent oil from getting on those contacts. The machines are constantly being oiled. Every month the guy would come out and re-oil a machine. So oil was always flowing around in the air on these machines. In fact, underneath the machine is a foam pad just to soak up the oil. And every now and then you'd lift out the machine and replace the foam pad. This is the keyboard restored. It's basically brand new. What's nice is this white plastic goes all the way down about 1/4 of an inch. So you never have to worry about the letters wearing off on your keys. The keys can wear down 1/8 of an inch. You'll still be able to know it's the H key. So my first question for award, we have awards for you here. These are 30 punch cards from Los Alamos National Labs, and they make great bookmarks. So, and I don't want anyone to answer who's been to my presentation before and knows what this is, but can you guess what this is? This is in a publication from Teletype. What is this, you think? Programmers? Teletype operators? Top employees? Okay.
Wives of the executive.
Wives of the executive. Well, it's close. It turns out every year Teletype had an employee beauty contest. So, Stephen, give the gentleman with the executive wives, give him the award. So what happened is each year they called it the Telepal Queen Contest. And what they did is they had 6,000 employees and they would nominate who they wanted for their nomination. They'd get about 150 recommendations. And then they would narrow that down to the most popular of those 150. And then they would have those 10 finalists actually tour the factory floors so the employees could meet them in the various buildings. And then the employees would vote for 5 finalists. And then they were awarded the the Telepal Queen at an annual ball that they held every year. And here's an example in 1962. These are the 10 ladies who were in that year. And it shows them going through the factory floors. And this is, I'm not sure what year this is. I have to check. 65. These are the 5 finalists here. And they even went where Teletype paid for all their gowns, paid for them to go to the beauty parlor, just did the whole thing, and then they announced it at the ball. And one of the things of winning was the lady's picture was put on the parking pass. So where if you were driving around Chicago, oh, they work at Teletype. So in addition to that, they became a representative of the company. And this is the lady who won in 1965. And here she is touring some customers. You guys may not know who this is, but this is the ringleader of Bozo the Clown. And they actually paid this man to do the MC of the Christmas party every year in Chicago for Teletype Corporation. So back to the Teletype. That was one little tangent. This is Teletype 2. It's completely restored. This here, I just want to show you, that's a bell. Stephen, can you turn that on and ring that bell a few times? That is much better than these little ringtones you get. But in the old days, and a news bulletin would come in, if there was 10 rings, it would mean Kennedy was shot or a war had started. But if there was like 2 rings, it was a much smaller article. So people could know, you're sitting in the office, there's 10 rings, oh, that's a really hot story. And so the news people would go off and pull it off and read it on the radio. For the second award, and we're going to pass one of these out, can I have someone guess what this device is inside the Teletype? Yeah, hand out so they can see them. Okay, some guesses? Yes?
Ink squeegee.
Ink squeegee. Oh, that's good. You, gentlemen.
That is for the tape. There's the yellow tape that comes through there, and that feeds the tape.
Okay, tape feeder. More guesses? Come on, this is for an award. 30 Los Alamos National Cards. Yes? Feed roller. You're very, very close, the last one. We're going to make you the winner. So, Stephen, give him... He basically said the key words, it transmits, and then he was very close. But what it is was called the answer back mechanism. And you could program in these devices to, when you do hit the answer key, that it would print out a 20-character message. So it had like a 20-character buffer. And these pins here, right here, each one of these rows is for an ASCII bit combination. So you break off the pins to represent an ASCII value. So what it would do is people would have a tape and they would dial a number in Chicago, and that machine in Chicago, if they hit the answer back key, the Chicago machine would play this little loop and they'd say, oh, that really is the Chicago machine. It's saying Chicago 713. So it was a way to get a little bit of security on who it is you were calling, and really was it the machine you were expecting. So that's called the answer back key. And you can see it right here. And when you press a button, and you can come up here later and press it. Why don't you turn that on in local mode and press that button. Hit the answer back. Okay, now turn it off. Basically, it just plays that thing. So what we did is, for these machines, I programmed with his name and my other son's name. So whenever they're doing a letter or something, they can just hit that key and it prints out their name. So now this terminal is done. So now we have two terminals. And I'll just show you a little bit of literature. This was the very first ASCII device that this company came out with. And you guys, I just came from the What Is My Name talk, where they were talking about, Unicode this, Unicode that, and these planes and all. That same world existed 50 years ago. And so they solved it by coming out with ASCII. Before ASCII, there was literally hundreds of machine codes. Univac used one, IBM used 5 or 6 different ones. Then you had NCR, and then you had DEC, and then they are all using different codes. We need a standard. So in 1963, they finally got it right, and they did the ASCII standard. So ASCII's taken for granted today. Before they went to ASCII, they were actually working in Baudot mode, which was a 5-bit character code. And just to give you an example, they had 60 characters that they could use in the 5-bit mode. So my question for you guys, for another award, is how did they get 60 characters in just 5 bits? Multiple alphabets. Shift codes. Yeah, okay. I'm going to go with the shift codes, Stephen. You got to give this gentleman some Los Alamos National. Oh, Stephen, those are IBM cards. Let's give him the Los Alamos cards. Oh, no, they're fine. The Los Alamos ones are more exciting. But what they did is they used what was called shift codes. So you had 2 to the 5th in 5 bits, so you got 32 possible bit combinations. 32 is not enough for even 26 letters and 10 digits. So you take away 2 characters to do shifting, and now you have 2 sets of 30 characters plus 2 shift characters. And actually what they did is, this is a null, and they had both of those in both codes. Then they had the letters, and then they had line feed, space, carriage return, and then this is letters and then figures. That's how they called the 2 sets. So if you were doing text, you could still do spaces and carriage return and line feeds, and you didn't have to switch to the other mode. But as soon as you switch to numbers, you could also do spaces. So they tried to optimize if you're in one mode or the other, but it was very confusing. The teletype operators had to say, oh, I'm going to do a letter now, and they have to hit a figures or a letters key, and then, oh, I'm going to do a number, I got to do a numbers key, and it was very confusing. So ASCII was a great advancement for them. And they did giveaways for ASCII. So here we have these paper tape punch cards so you could read the tape holes, and they had pictures on them. So these were like marketing devices to sell ASCII. And this card showed you, if you wanted to T, you could figure out the bits or how the tape was punched. So if you were looking at a tape, you could say, oh, that's a T. And Teletype made about 700,000 of these machines. This particular model. The 500,000th machine, they plated in gold, and they put it in their museum. And in 1976, which was the bicentennial year, they did, I think for the 700,000th machine, they painted it in red, white, and blue and had it go around the country. There might be, I would guess, 1,000 of these machines left today, and like I said, you see 10 or 15 a year on Craigslist. Okay, so now we got the machines, a little history about them. Now we got to get them to talk to Linux. So we have a current loop signal which goes from 75 volts to 0, and it's basically the current is always on and then it goes down for the data bits. And then we want to get that to RS-232, which is 13 volts to 13 plus and minus, with a similar pattern. But here we needed one stop bit. Up there we had two. So there's a few other things we got to do. So my first step was to get to RS-232. And I just took a passive device that takes current loop, turns it into RS-232. And that was an off-the-shelf black box device. And it costs about $270. You can still buy them today. You can get them for 50 to 70 bucks on eBay. But now we're to an RS-232 value signal, but we're at different baud rates. And in addition to that, we have other issues, such as the teletype's only uppercase, while Linux can take upper and lowercase. And that's just one thing. You know, I need curly brackets to program in Perl, and this teletype doesn't have curly brackets. So I need a custom device to do a little more work other than just switch the baud rate. So it's got to switch the baud rate. It's got to convert uppercase to lowercase. It's got to handle Control-C locally. So when you hit Control-C, it flushes out the buffers. Needs 2 stop bits versus 1. I want to convert the vertical bar, which doesn't exist on a teletype, to a 1. And then the auto force carriage return at the end of each line. This teletype will keep printing in the 80th or 72nd character if you don't have a carriage return in your file. So you want to make sure you add carriage returns if there's a long piece of text coming out. You want to have a variable time delay, so when you get to the end of the carriage return, you got to wait for that carriage platinum to get back before you print the next character. And then I wanted them to be able to enter any ASCII character. I wasn't going to go Unicode or anything like that, but at least they could do every ASCII character. And then I built in a macro capability so they could do shortcuts. So I paid this engineer to help me lay out the board. He gave me a design, and I wired it up on a breadboard. It basically uses Atmel Arduino type chip. Then I kind of designed a functionality. Character comes in, it goes into translator, goes into a ring buffer, goes out to the TV teletype. We're coming back the same way. And then I had a few escape sequences with some shortcut memory, and I have a couple local commands so I could get information, what's going on in this device. So I first started out with Arduino, and it was really limited, so I switched over to Atmel's Studio 6, a tremendous advancement over the Arduino. And it was all written in C++ and assembly using interrupt subroutines and so forth. And I was going to say, some of the things that the software did is it had a polling loop to do the serial at the very low rate for these teletypes. I just, polled an analog output signal that I turned high and low based on what my clock was doing. And it cycled about 50,000 times a second, so that was plenty fast enough. I built my own 16-bit precision clock. I'm just using the features of the Atmel chip, but I wrote my own precision clock. And then I used the EEPROM, it was about 2K, to do all the local storage. So you can actually program on the teletype. When I hit W, I want the weather. When I hit N, I want the news. And it sends those commands to the Linux machine. So then I got everything working with my prototype. I have these terminals simulating the teletypes. It only takes about 2 seconds from when you press this download button here in the server, in the Atmel Studio, to go through that programmer and reprogram that chip. It was a very fast, iterative process. I never got flow control working with the hardware, not sure why, but I ended up going with X on, X off, which is a software form of flow control. Then I needed a board, so I laid everything out in a program called KCAD, which is from France, and it's a hard-to-learn program, but once you learn it, it's 2 keys, you use it at the same time, it's really fast. In fact, even Stephen designed a board for his science fair project using KCAD. And Steve, why don't you hand out the board that I did so they can see. That was the first board I did. And this is showing the software here. One of the nice things about the software is it lets you see everything in 3D. And you can rotate this board in 3D. And when I did this, I actually found an error. I noticed that there was a little gap between those two wires. And sure enough, the little via point, it's called, was not there. And so I would have had to open a break in my circuit. So that was nice to find that. So then I sent these off to China for $100. I got 10 boards. And they came back, and they were in very good condition. Quality looked great. I put all the chips on, and it didn't work. So, and this was my first project, and I had no clue. You know, okay, try this voltage, and the voltages were a little bit off. But I eventually figured out in about 2 hours that this device right here, my regulator, the leads were backwards. So instead of 1, 2, 3, I had 3, 2, 1. So it was not working too well. So all I did was take that device and I mounted it upside down and put the heat sink on top of it, and it worked fine. And it still, you know, helped with the heat, so it was no issue. So it was a very minor problem, and that was the only one I found. Then I put it in a box, and you can see them down here as they work on the system. So now I needed some Linux system to talk to, and I had this computer, and it was just available. And I loaded CentOS OS 6.0, and there was nothing special. It was a straight install. So that was easy. Now I needed some software. So I wanted to get news, weather, wiki, so that the kids could just type in news or weather, and it would go off of the cloud and get that information. So I'm going to show you a few things I did with that. Let's see if I can transition nicely. Now this was the weather program. I wrote it all in Perl, and here's a bunch of my test cases. So like this will get the forecast for 3 days. So if I run this, it goes off to, I think it's weather.gov. Did I hit run yet? Yep. And so there, it went and got the data, and it prints out a little bit of, this is local to our house, so it's telling the information at our house. And I just formatted it for the teletype, make sure no line is longer than 72 characters. And so when you type weather here, it's running this program. So I did a couple others. News, this goes off and gets the Drudge report. So if we run that, it goes off and reads the columns and prints them out. So you see top of the heap and the main headline and what's going on, and it prints it out all in ASCII for you. And then I did Wikipedia, and then we did a little doctor program that the kids can run. It's a gentleman at MIT wrote this about 30 years ago. And so that was the scraping I did. So now let's go back to here. So next, I used Modulicious to do some of the scraping. That made it easy to traverse the DOM trees. But next, I wanted to be able to do program in Perl on these machines. And I had to do that using a source filter because the teletype does not have any of these characters. Curly brackets, it doesn't have a tilde, it doesn't have a vertical bar. And you need those to really program in Perl. They're pretty crucial. So I mapped these to some other characters using a source filter. And so this is the beginning of the code. So if I type a bracket B bracket, which the teletype can type, it substitutes for a curly bracket. And so here's the actual source filter. There's really no magic. It's right here. It's mapping this to the character that I want. And this is a program now written using this method. So here's my open bracket. These are my closed brackets. And so when you run this program, it prints this out. And so the question is, okay, what was that? Well, this told me what pins to break off on my, here is wheel. So if I followed that pattern, then I could get, and I can't tell you how many mistakes I would get the columns wrong, or you break a pin off or 2 pins, and these things we're going to have to 3D print them, but you can't get them anymore. Okay, so then I loaded some utilities, standard utilities like ED, BC for a calculator, Cowsay, kids enjoyed that, time, date, calendar. And then I put email on it with postfix and fetch mail, and I have all that working. So if you guys type in mail and your address, you can actually send an email to your phone. Then I added some games. I went and got some old libraries and got Go Fish and Monopoly, and I wrote the doctor program using a CPAN module. So then I had all this working or running, and I needed a manual for the kids. So I wrote a manual, and if we go here, here it is online, and so all these topics are here. So if they want to know how to run the reverse command, right there, it shows them how to do that. So there's a complete manual of everything, how to set it up, how to run it, how it should be wired, how to turn it on, things to do for fun. Now let me go back to... I'm a little bit out of sequence here, so let me, here we go. Okay, we're back. So I wrote a manual, and now this was the first time I had everything working. And I had quite a smile on my face. Yes, Stephen? Yes, why don't you hand out one of the manuals so that they could take a look at that. And this shows the day I had it running for the first time. It happened to be when the Malaysian airline went down, which was about a year ago. And I had it set up so that when you log on, you get a quote from Spock, or when using the Fortune utility. Then next I trained the kids how to use the machines. And here they are laughing at the doctor program. And now, basically, that's it. We're going to let you come up and try the machine soon. But I want to talk a little bit about Teletype Corporation, give you a little bit of a history on what that company was like. First of all, how were teletypes used? In the old days, they were used over phone lines to send telegrams. And before that, just to send, telegraphic messages. They were used in the military heavily during World War II. The radio signals were sent encrypted, and then they were decrypted, and then they were printed on teletypes. And then in business, this is some of their advertising, which was about the period of these ASR 33s. They said they could use it basically in anything. This was an interesting machine. This is a wall-mounted teletype, and we actually have one of these at home. And we're planning on installing it in the kitchen so that when I come down in the morning, it's got the weather, it's got the news, and it has how much money I've made on my few sites that earn a little bit of money. I can just rip off the paper and I'm informed. So a little bit about the company. They made almost every product that went into these machines. They did not outsource hardly anything. So here you see a guy who, all he's doing is bringing in raw materials. Sheets of steel, sheets of copper, sheets of whatever they were using. And almost everything was nickel plated so that it will last almost forever. They also had tons of engineers. This was like 1967. They had about 500 engineers, and they would have a whole week, which was called Engineers Week. And they would bring in people, talk about engineering topics, and try to get cross-fertilization in the various departments. They also had an awards program, and this is in 1967, and the gentleman in the center here, he got an award, $555, and that in today's dollars is $11,000. So these were significant awards, and they did this every month to all the suggestions that were sent in by the employees. This is an interesting thing. This is actually a scheduling mechanism for their computer system to decide who's going to use the printer for payroll, who's going to use the printer for accounting, who's going to use the printer for this. And all this does is these little bars are like who's going to use the computer time when. So I thought that was interesting. And I love his title. It's Computer Peripheral Operations Section Chief. They had a family day where they would bring in all the employees' families to see what they do at the company. They had many clubs. I mean, look at all these clubs: photography, chess, hobby, radio, badminton, dancing, Boy Scouts. Then they had a hobby show each year where all the employees would come in and show their hobbies. And this one, I didn't know what this was. Someone told me graph analysis is handwriting analysis. or handwriting analysis. This is another picture, and this is for another award, Los Alamos Cards again. I would like some guesses on what this picture is.
Boy Scouts!
That's not the Boy Scouts. Shooting club. Hole punching. Marksmanship. Well, it is a shooting club, so let's give this gentleman, the gentleman in the white shirt there. This actually happens to be, see if I can get this to work, the Illinois Bell Rifle Team. And this gentleman right here helped me a lot on this product. This is Don, and he used to repair these machines, and I got some advice and parts from him. But they used to compete with the Teletype Gun Club. In fact, Teletype had multiple gun clubs. They had, this is the, this says, I think, small bore, but they had different types of weapons, different clubs for each of those. But it's very different from today. I mean, how many of your companies have gun clubs? They also had an evening school. And this is from their art class. And this is some artwork done by the employees. And in addition to art, they had all these different topics. Beginning Russian I thought was interesting. They had screw machine theory. Screw machine theory, right. And they had Heathkit, which I thought, that's dead and gone. They had cartoon, which is interesting. And modern math. Slide rule, too. Yeah. They also had a choral group that sang concerts, and here they're playing for a hospital, and their next concert was going to be at the Tool and Die Institute graduation ceremonies. And they practiced in the cafeteria every Wednesday if you wanted to go hear them. They also had an annual picnic. This was quite legend for their company. This was a big event, and a lot of people talked a lot about those picnics. And this was their headquarters. This was the main building. It was built in about 1960, and it was just outside of Chicago. And just give you a little perspective, this is AT&T, who eventually owned Teletype. They were bought by Western Union, which was a big telegraph company. No, Western Electric, sorry, I got that wrong. Western Electric, and then Western Electric was owned by AT&T. So you can see here, Teletype, this is all the Bell companies like Illinois Bell, New York Bell, and then AT&T. This is Teletype, this little bit, and it was about 1% of all of AT&T. And it was shut down by AT&T in about 1990. And this is the headquarters building being torn down to make way for a new shopping center. So that's the end of the presentation. A little bit of contact for me. This is my contact number. So just remember 77.04. And you might ask, well, how do I use that? Well, you add that to Pi. And it turns out you get that number. And the first sets of digits there is my cell phone number. So you just got to remember 77.04 plus Pi. Then my email's there, and also information on the whole restoration project is on the website there, that address. So the last award for the best question, before we go to the demo where you can come up and try these machines. Do you guys have any questions that you want to ask? Yes?
What inspired you to undertake the project?
I've just always been impressed by the mechanical ingenuity that's gone into these machines. And it's a real challenge. I mean, it's a lot better than watching TV. And it's something where when you're done with the process, you have something you can actually use. You know, I hope to have it in my kitchen telling me the news each morning. But it's just a fun project where you have a goal at the end. Yes? Not yet, but it's a wall mount unit, so it's going to be fairly small, and we have the perfect wall for it. Yes? Do they have a Twitter account? No, but they are connected. What's that? Yes, that's true. You could send email to the address that you get from here, and it would come in here. So this has two-way email. Any other questions? Yes? Yeah. Not really. There's not much going on in Utah. But there's one other gentleman here who collects Tektronix machines. But he and I are probably the only two guys in the state who have, let's say, extensive pieces of equipment. But there, in the U.S., there's about 100 people who do restoration of these machines, and we trade them back and forth and, help each other out. And it's actually a lot of fun. Any other questions? Yes?
How reliable are they since the restoration?
They're quite reliable, but they're not designed to be perfect. They even tolerate, I think, one error out of every 10,000 bits or bytes. So they do expect errors, and it's a tolerance type thing. They can get out of tolerance. But they're pretty reliable. These are actually designed to be throwaway machines, this particular model, but it ended up being so popular that they kept reinforcing it and fixing bits and pieces that turned out to be a problem. But they're pretty reliable. And they're pretty easy to restore because they're, number one, filled with oil. And oil means if it's providing it's not been in a barn with cats and rats and birds and mice, then it's usually in pretty good shape and it's easy to restore. Any other questions? Yes?
Where do you get replacement parts? Does anyone still make parts for you?
Nobody makes parts for these, but you can get all the consumables, the paper tape. There's plenty of paper tape around, the ribbons. And just most of these parts are pretty simple. Yes?
How'd you end up with punch cards from Los Alamos?
Well, that's another long story, but there was a guy there who collected amazing stuff. Well, we went through his warehouse and got a bunch of stuff, and we ended up with a bunch of stuff from Los Alamos National Labs. Yes?
Programming Perl on the Boomerang Act.
Oh, we use ED. So, got to use ED, line editor. Any other questions? Yes?
What's the time scale of the oiling and then also
The oiling and then what?
just like taking them apart and rebuilding it?
Well, it took about 6 months to restore each machine. It's just, a few hours here, a few hours there, maybe a couple weekends. So it really depends on how much time you had. If you had a month, you could do it in a month easily. And the other good thing is it's so well documented that even with no help from anyone outside, you could probably figure almost everything out from the manuals because they were designed for field technicians to go in and do all this work. And everything's very modular. With just a couple screws, almost everything comes out of there. Yes?
It's really cool that you've got it hooked up to Linux and running Perl, but I'm wondering how long until you've got the Linux kernel and Perl 5.4 running in the teletype machine.
Yeah,
That's what I was hoping to see.
I don't think I'm going to go there that far. Any other questions? Yes?
What's the best response you've gotten from someone you've shown this to?
Well, I don't know what you mean by best response. The room here has been good, but it's fun to see this old technology still work. And, we will still be using these things 100 years from now because we're still going to be reading and writing text. And, people aren't going to be reading and writing images. So unless that changes, these machines will still be fun to play with for many, many, many years to come. Any other questions? Okay, with that, we're going to move to the demo, and where you can come down. Here's a couple rules. Be gentle with the machines. You can come up here and use them. Don't type 2 keys at one time. And ask before you push an unknown button. If you don't know what the button's going to do. And no malicious shell commands to take over the system or create a kernel panic. So, and to send an email message, all you got to do is type mail and your address, and it'll ask you for the subject, and a single period will end the message, and it'll show up on your iPhone. Yes, Stephen?
Did you forget to hand out something?
Let's hand out the card to the best question. Who had?
The best question.
You did? No, I don't think you did the best. Let's give it to the gentleman there with the suit jacket on. Okay, thank you very much, and that's the end of the presentation.